So in the previous video, we showed our AMLogic device, we showed its interfaces, we also talked about how to glitch the eMMC, we talked about how to hackily reset it, other than like taking on and off like the power of the USB cable. And we observed the eMMC block device, mentioned that there is like this @AML header, and we talked about like the hardware partitions, and we showed what happens when we just wipe like the eMMC block device without the so-called hardware partition. And we also then went and wiped them also, at least part of them, like with these headers, and so that the device no longer boot. And later we saw like how to actually recover it. So this is what I called wreaking havoc on the device. We destroyed things that the bootloader expects, because it's going to load like the hard-trusted firmware from like the eMMC, and or from an SD card, or in a way from a USB. There are also, by the way, all kind of tricks by showing something on the I2C bus and some specific like ID when you connect like an HDMI dongle to it, and then you can force it to boot like from a USB stick and yada yada yada. But we did show how to do like a device recovery with the AML flash tool. So now I'm going to show you, once we wipe the eMMC, what happens and what we can do. So on the previous video, we used this nice TF card, okay, TF debug card, that is nice, it does the work, but there is one issue with it comparing to just wiring the TX, RX, and ground of you know, like to the device, and using like a TTL to USB adapter, like to actually have the serial. This TF card and its debug abilities, they are not available from the boot ROM. So there are some messages that you can just have blind faith and know, hey, they are there, but not all. They do appear if you have like the right like UART connector. So for now, I also connected UART. I try to avoid it whenever possible, because when you soldier all kind of things and you travel then, or just do some small hacks, things can be destroyed sometimes. And if you can just work with USB or like with another adapter that you pack fine, then it's great and no problems with it. So that's what I've done, and I want to show you what happens when I power on this device. Okay, so I'll do two things. Right now on my device, I have the USB connected into the USB cable port, okay, and I put the message here. All right, and I will connect the cable. Let's see, and we can see that the device is identified. And look at what else we see. You see these prints here: GXL, BL1, blah 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 blah, USB 8, SD800, eMMC 0, read 0, and so on and so forth. So there is this status line, okay, and there should be loop counters somewhere, I think. Okay, so there is this status line. All right. Now I have a card that has like my own flashed bootloader right here. I'm going to put it like on the device. It is connected to the USB, like the USB itself is connected to the USB debug place, and nothing happens. Okay. I mean, I wiped the eMMC, but right now nothing happens. So I'm not too happy about it. Let's disconnect the SD card and start over. Okay, so I'm going to take off the USB cable from the device itself. This is why there is a disconnection event. I'm going to start over here because the text can overlap. It has like this loop counter, and now I connected the debug port to the other port. Okay, and we can see that it loops 1, eMMC 0, read, blah 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 blah, and so on and so forth. Okay, let's go ahead open and close this, and we can see here that we have different like status lines, we have loop 5, eMMC, and so on. Alright, and USB is like in 8, and we do not recognize the device here. Back again, I'll do the other one. With the other one, with the debug port, we didn't see like this eMMC loop. Okay, so I already powered it. And this is what we see. We do not see like the loop. Okay, good. So what I'm going to do is connect it again to the other port. You can see like the print once again here. Again, now we will see like the loop. Okay, loop 2, eMMC here, eMMC there, everything is good, everything is great. We can compare it to what we saw before. Okay, so we see like POC 3, let's do that again. This is the looping one. I'll disconnect and connect it. And this is like what we got like in the loop. So here are like the different things. Here we'll have like a loop counter after each time, but other than that, they look identical. Okay. Now, why do I even bother to mention it? Because now that I'm not connected to the USB debug port, and it's actually important, I'm going to, what it is how we flashed like via USB before, and we can also boot like a live system without flashing if you want. I'm going to connect an SD card. Alright? So look what's going to happen. Just double checking that the device is disconnected, which it is. And I will connect an SD card now. It will keep looping. This SD card has its own bootloader, and look what happened. So we can see somewhere here, yeah, Ubuntu 2026. You heard this sound? Listen. It's because I played some sounds. I don't know if you heard it, but now we have something that is running. This is my own code. Turn on the volume, it's not going to be so pleasant. I didn't play sounds here because the sound that I recorded were very, very low sample rate. Okay. And now I have my Linux device. I rebooted it and the SD card is still inside, so now we'll hear like a sound. Or it's not supposed to hear a sound. I fixed some of like the audio playing code. Okay. So we heard some sounds. There are notes like in the code about some things, like when you work with audio, you need to synchronize, you need to know how to have a underflow, and you need to be very attentive to the device status. Okay, but we heard some. If you heard some sound, I made them like a little bit loud. Then it came like from like the sound via the HDMI, and it's like some of the features that we have here. So if you saw, so we saw enough from this. I'm disconnecting the USB and the debug prompt. So what we saw in this video is what happens if we actually want to like have like a software on it. Okay, so now because my code actually flashed it, I removed the SD card. I hope I didn't disconnect it when it was like we're traveling. we hear like the sound. That's okay. Yeah, maybe it's USB 0 now. Yeah, it's USB 0. And if we do etcd, yeah, it means I already burned it. Yeah, so this is the file system that I have, okay? And if you saw like the OTA videos, I can now serve it like with another OS, like the Debian one. So it wants to get the HCP. It doesn't really matter for the sake of this video, but let's make it happy. Now let's connect a network cable to it. Why not? I like to make people happy. So we can see like the carrier is identified. And I mean it has like this loop, but it will discover something sooner or later. Okay, so we have like an address, which is good. Okay, so what we had in this video, we saw that we can actually like wipe stuff. And now actually there is something a little bit like more interesting. So let's say I want to wipe thing again, okay? So I mean I prepared it ahead of time. I will kill here also like the other ones. Now I'm on Linux, okay? So I have like this uname-a. I will kill OTA. And we can see that this is like the kernel version, okay? It's 6.19. So now I'll do like our regular things. It's now another other block because it's no longer Android. I'll copy paste all of them, okay? And look what happens. I mean, the first one goes without any issues. But what about the other ones? So for the other ones, we can see operation not permitted. Why the operation is not permitted? Because Linux knows to write protect those variables. This is why I also placed it like in the video description this time. I was hoping that other people will write it or that I will transcribe it, but I didn't want to do it really. And basically we can disable write protection by writing to sysblock, mmcblk, like the partition, and force RO. So if we cat it, we will see that it is indeed 1. So if we do echo 0 to this one, then we will be able to actually to do the right. So we'll do it to the first one, it will succeed. If we do it to the second one, it will fail. Okay, because we did not we did not like unblock it. So this is good. Let's do sync. Let's reboot this one. And we see this again because the eMMC is not set. Now this time I did not, you can see that I did not flash the second partition, but I wiped it before. So it's still like not recognizable. Otherwise, if there were boot code there, then we would not see like this loop. We'll see a status line only like one time, and then we would have things working, you know, the way they work. So again, I'll put like this SD card. We have like this loop, and it recognizes it. And somewhere here, I'm going to write. The sounds are intentional, okay? Somewhere here, yeah, replacing your U-boot firmware and boot code. This is where I actually put things like on the eMMC partitions, and I could, if I wanted, unprotect the partition and do like the other things. Okay, so I finished the flashing. This is good. I'm taking off like playing like this octave and having like these things now it sounded nicer. I'm going to reboot it, and I'm actually going to stop at U-boot. So basically I have like my own U-boot here, and if I do mmc list or mmc device, we have these devices, and if I do mmc device 0, sorry, mmc dev 1, okay? Sorry, MC rescan. I don't have the card connected here, okay? But let's see what devices we have. MC dev 1. It should not matter really. MC dev 0. That's interesting. This is not supposed to be the problem. Maybe a little reboot will make it happy. MC2. Okay. Interesting. That's interesting. Okay. Perhaps it has to do with me. It's usually going to be like the MC1. Okay. But anyhow, you'll see. I mean, now I put it like I don't know why it is. Maybe I actually don't know why it is. I usually use like the power cable, not the USB. It shouldn't matter. Whatever. Anyway, so here, look what we have. Like we have, this is an encryption related device. Forget about it now. We have this boot capacity. We have the user capacity. Okay. So this is also why we don't have the entire like 16 gigs, because we have several other partitions, boot area and boot area 1. And now here it tells us that it's not write protected, so we can write to it directly. And now how do I get to these partitions? If I go and do mcdev2, let's do 1, okay, and I do mcinfo, then I mean, it's supposed to. Yeah, okay, so it switched the partitions. This is what I wanted and expected essentially. If I do mcdev2, it doesn't matter. Like if we have like the 2.0, this is like the main MC device, okay? And if I do, for example, let's do, see that load address is defined. It is. If I do mmc read, the block size is 512. To load address and let's do 1 block. I mean, that's fine. Okay. So I'll start from 0 and I read 1, and then I'm do md.b load address, and then let's give it 200. So this is what I have, all kind of things here. Now if I go to if I change the device, so that's what I have like on this device. Somewhere I should find AMLogic if it's if it's like the first device. Let's go to this one. It's 0, okay? Let's go to 2. It's zeros. These are the things that they zeroed before, okay? This is why they're not accessible. And let's go again like to 0 here. And let's read. let's read some more things here. Okay, so I said read load address, let's do 0.4, okay, and let's do the memory byte, and let's do it here 800. So we see, okay, I didn't read enough. We see like this AML here, okay, and that's the header, and everything is just fine. Okay, so it appeared like a little bit after the first sector. That's fine. So that is what we saw, and this is why the device boots. Let me just go ahead. I will not do reset, I will just disconnect it. I am pretty curious about what happened like with the boot here. I'm connecting to the debug port now, it doesn't really matter. MMC scan, rescan, heard it not, it doesn't matter. MC list, yeah, so it goes like over like the same thing. Quite interesting. Maybe it has to do with the bootloader that I built. Maybe there are issues there. I just built like a mainline one with a config. Interesting. Yeah, it still gives that. And if I go and put like the card, let's see what it will give us. I'll do mmc rescan. It doesn't matter. Let's do mmc dev1. Okay. And I'll do wow, maybe I didn't build anything into it. Yeah, okay, so I have fatls mmc 11. Yeah, so that's the device that I had. Okay, so it's fine, and yeah, interesting. So no matter what you do, what device like you get, identify your MMCs, otherwise you could write to the wrong places. And it's pretty weird that there is no like this 0 here, but now it's not write protector, we can write to dev in this case too. And in this video we covered what happens when we connect a proper serial interface, okay? And we also saw what happened when we actually flash a device. And having this knowledge, we can now, from this video and the previous one, we know how to recover like to a vendor image via like the USB tool. And we also know once we wipe the eMMC and force the device to not boot to it, which is the more elegant way. The other ways would be like to desolder the eMMC and then it will not go to the eMMC. Or to glitch the eMMC and make sure that it's not identified or that the bootloader cannot properly read from it. Once we do that, and we have an SD card that actually has the right bootloader, which is what I built, and I have it like on the PscgBuildOS, and I have another open source project that shows like how to build that, like it explains it. And once we have this, we are actually able to put our own software, our own Linux on an SD card, and then from this point we can move on and work with the distros that we are manufacturing. But very important, like a lot of like modding instructions, they don't go over replacing like the bootloader. They expect to use the mechanisms of the existing bootloader. So they will look for like boot script over like the first fat partition of an SD card, and then do all kind of things. So we do not do that. We say, okay, we treat the device as if it were pristine, and I show you the techniques by erasing like the eMMC, at least the blocks that the boot ROM would be looking for, to get like the bootloader chain, the untrusted firmware, and then the U-boot. I show you the techniques to have the device like a pristine device and work with that. So I hope this is useful. It's very useful if you work with its devices and try to modify things. And one last thing, I think I said it like in the summary, but I showed the difference between having like, all those like TF card, debug cards, and hourly they kick in. So you will not see like this boot loop like that will tell you, hey, like this device is like alive, or hey, I recognize an SD card, I don't recognize an SD card, there are all kind of statuses there. If you don't connect the TF card, and if you connect the USB debug port, then the SD card will not load. It's very, very, very important. But if you connect the USB debug port, you can actually load an image over there. This is actually what the flash, this is what the AML flash tool does. So it flashes like the bootloader, you can do it like yourself. And this bootloader also recognizes that it's like in a burn mode, USB burn mode, and then it receives all kind of USB commands as we saw earlier. So that wraps it up.